welcome to the deep dive. You're interested in how those open source AI models are challenging the big names like GPT-4,
Right.
specifically how they're handling massive amounts of information.
Yeah.
It all comes down to something called ChatQA2. We're diving deep into a research paper called ChatQA2, Bridging the Gap to Proprietary LLMs in Long Context and RAG Capabilities.
Wow.
Get ready. This one's a little technical.
Yeah, it's a fascinating area of research. We're seeing a push for transparency in AI open source models like ChatQA2 are really interesting because they make all their workings public, allowing for collaboration and scrutiny.
Absolutely.
Yeah.
So what is ChatQA2 all about? What makes this model so special?
Well, ChatQA2 is built on Llama 3.0,
Okay.
and it focuses on two key challenges in AI.
Okay.
One is long context understanding, and the other is retrieval-augmented generation, or ARAG.
Okay, so long context understanding.
Long context is being able to process hundreds of pages of text at once.
Oh, wow.
Like feeding an AI an entire textbook and having it answer your questions.
That's incredible.
Yeah.
Okay, so that's long context. What about RAG? What is that all about?
Imagine giving an AI a super-powered search engine.
Okay.
It can sift through tons of data and pull out the most relevant info.
Wow.
To answer questions or complete tasks. It's crucial for real-world applications.
Yeah.
Where you need to access information from various sources.
So ChatQA2 tackles these two key areas, long context and RAG. What makes it even more interesting is its open source nature.
Exactly.
Right.
The developers made all their work public.
Wow.
The model itself, the training data, even their evaluation methods.
That's great.
This allows researchers to study and improve it, leading to faster progress.
Yeah, it seems like there's a context window race going on in these large language models.
Right.
Why is the size of this context window so important?
So the context window is basically the AI's working memory.
Okay.
A larger context window means the model can process more information at once.
Right.
Proprietary models like GPT-4 Turbo and Claude 3.5 have massive context windows.
Huge.
Like 128,000 and 200,000 tokens, respectively.
Wow. That's like processing several pages of text simultaneously.
So are open source models lagging behind in this context window size race?
Not really.
Yeah.
Models like Gwen 2 and Yi34B are also boasting large context windows.
Okay.
But it's not just about cramming more data into the model.
Right.
It's about ensuring it can actually understand and use that information effectively.
And this is where it gets really interesting. The research paper talks about two main approaches to extending these context windows.
Yeah.
Position interpolation and increasing something called the Rho-E base frequency. What are those?
Well, both techniques deal with how the AI represents the position of words in a sequence. Imagine the model has an internal clock that tracks where each word falls in the text.
Okay.
Position interpolation is like giving the model a way to adjust that clock.
Okay.
So it can still tell where words are, even in very long sequences.
Oh, I see.
Yeah.
Okay, and what about increasing this Rho-E base frequency? What does that do?
It's like making that clock more precise.
It allows the model to distinguish between words that are very close together, even within a huge amount of text. Think of it as enhancing the model's ability to understand subtle nuances of word order and relationships.
Okay, so ChatQA2 is using some serious tech to handle these long contexts.
Yeah.
What's unique about their approach?
Well, ChatQA2 uses a special way to separate documents within the text.
Oh.
Instead of using standard end-of-sentence markers, they use special characters.
Okay.
This little tweak makes a difference in how well the model understands and processes those long sequences. It's a reminder that formatting can impact AI understanding.
It sounds like ChatQA2 goes through intense training to handle these tasks.
It does. It's like a 3-stage boot camp.
Okay.
First, it learns basic instructions on a massive data set.
Right.
Then it's trained on conversational question answering.
Oh, wow.
So it learns how humans ask and answer questions.
Okay.
And finally, it tackles super long documents to test its understanding.
So it really gets put through the ringer.
It does.
That's fascinating. And then, of course, there's R giving the AI a search engine.
Right. And ChatQA2 has a unique approach to RAG.
Okay.
Especially when it comes to long documents. Traditional systems break long documents into small pieces, which can cause the AI to miss important context.
Okay.
But ChatQA2 uses a long context retriever called E5 Mistral.
Wow.
That can handle thousands of tokens at once.
So it doesn't lose as much information.
Exactly. It leads to more accurate and complete answers.
So ChatQA2 combines this long context model with this advanced retrieval system.
Yeah.
How did the researchers test it?
They use several benchmarks designed to evaluate different aspects of the model.
Okay.
One of these is Infinite Bench,
Yeah.
which focuses on tasks that require understanding over 100,000 tokens.
Wow.
Things like summarizing a novel or answering in-depth questions about a huge document.
That sounds pretty challenging.
It is.
Were there any other benchmarks?
Yes, Scrolls and Long Bench focus on shorter documents up to 32,000 tokens. And then there's ChatRag Bench, which is specifically for conversational question answering.
Okay. So how did ChatQA2 perform on these?
The results were really impressive. ChatQA2 did very well across all the benchmarks.
Oh, wow.
It even rivaled GPT-4 on some tasks. It really excelled at that ultra-long context understanding.
So it sounds like open source models are catching up,
They are.
and they're pushing the boundaries of what's possible.
Absolutely.
It seems like this combination of long context models and advanced retrieval systems is really unlocking some incredible capabilities.
Yes.
But is there a clear winner between the RAG approach and just directly using a long context model?
Well, the researchers looked into that.
Yeah.
They wanted to see if RAG could improve performance,
Yeah.
even when using a strong long-context model like ChatQA2.
Right.
What they found was quite interesting. For documents up to 32,000 tokens,
Okay.
RAG actually outperformed just processing the whole document.
Wow. So even with those long context abilities, RA still has its place.
It does.
What about those super long documents, the ones over 100,000 tokens?
For those, RAG is still the better choice.
Oh.
It shows that even the most advanced models can struggle with huge amounts of text without help.
It's almost like they need that guidance to focus.
Yes.
So both approaches have their strengths depending on the document.
Exactly. And having a model like ChatQA2 that can do both well
Right.
gives developers more flexibility.
This has been a fascinating look at ChatQA2. It's incredible how these models are evolving and the potential they have.
Yeah.
In the next part, we'll explore Figure 2, which shows how the size and number of chunks retrieved can impact RGAG's performance.
Sounds good.
Okay, so let's take a look at Figure 2 from the research paper.
Right.
It shows how the number and size of those chunks that the RGAG system retrieves can affect its performance.
Mm-hmm.
I'm curious to see how that all plays out. I mean, it feels intuitive that if you're giving the model more information, it's going to do better. But I wonder if the size of those chunks also makes a difference.
Yeah, that's a key point. As the number of tokens the model uses goes up, the accuracy tends to improve. But the chunk size itself also plays a role. They experimented with different sizes, 300, 600, and 1200 tokens,
Okay.
and found that larger chunks generally led to better performance, especially when using a lot of them.
I see why that would be the case. Keeping more of that original context intact.
Right.
You're reducing the information loss when you break things down too much. But wouldn't using larger chunks also mean that it's more computationally expensive?
That's true. There's always a balance to strike between accuracy and efficiency.
Right.
But remember, these models can handle tens of thousands of tokens at once.
Yeah.
So even with these larger chunks, the computational cost is manageable.
Right.
Especially when compared to those gains in accuracy.
Okay, so it sounds like finding the right balance
Yeah.
between the number of chunks and the size is key.
It is.
When you're using RAG, it's
Oh.
about finding that sweet spot for your specific task.
And that's what's so great about ChatQA too. It handles these larger chunks without problems.
It gives researchers more options to work with.
The paper also dives into that comparison between the RA and the long context approaches, particularly with Table 5.
Yeah.
What stood out to you there?
Well, Table 5 highlights those performance differences when we're dealing with these ultra-long contexts, the ones that go beyond 100,000 tokens.
Okay.
They looked at two specific tasks, from infinite benching QA and NMC,
Okay.
both of which involve question answering within extremely long documents.
Yeah.
They tested both ChatQA2 and another model, Qwen272B Instruct.
Wow. So they're really putting them to the test with these massive documents. Did one approach stand out as being more effective for those ultra-long contexts?
In those scenarios, RAG did better.
Okay.
Both ChatQA2 and that Qwen2 model achieved higher accuracy when using R compared to just processing the whole document directly.
That's fascinating. Even with those large context windows, 128,000 tokens, it seems like having that targeted retrieval mechanism that RAG provides still gives the model an edge when it's faced with just a mountain of text. Why do you think that is? I think it probably comes down to the sheer volume of information the model has to process. Even with those advanced architectures, there's a limit to how much a model can absorb and utilize effectively.
Right.
RAG helps by pulling out the most relevant chunks,
Right.
allowing the models to just focus on what's really important to the question.
So it's not just about how much information you can fit in that context window.
Right.
It's also about making sure that the model can use what's actually important.
Exactly.
And it seems like RAG provides that sort of targeted approach,
It does.
especially for those huge documents.
Mm-hmm.
What are some of the practical implications of that finding?
Well, think about tasks that involve processing just huge amounts of text, like legal documents or scientific papers.
Right.
In those cases, RAG could be more efficient and accurate
Right.
than just relying on those long context capabilities alone.
One of the things that really impressed me about this research was their commitment to transparency.
Yeah.
They made everything public. The model weights the training data, even that evaluation setup.
It's crucial.
This open source approach seems to be driving a lot of progress in these large language models.
It's absolutely essential for the field call. Open source models like ChatQA2 allow researchers to build upon each other's work, leading to more robust and innovative models.
This whole context window size discussion has been really insightful. We've seen how models are pushing those limits of what they can handle.
Yeah.
But I want to shift gears for a second and talk about the ROPE-based frequency.
Okay.
The paper mentions how adjusting this frequency impacted the model's performance. Can you explain that a bit?
It gets a bit technical, but it boils down to how these models represent the position of words in a sequence, which is really important for understanding long contexts. Think of the ROPE-based frequency as a measure of how finely tuned the model's internal clock is for keeping track of those positions. A higher frequency allows for more precision, so the model can differentiate between words that are very close together in that long string of text.
So a higher ROPE-based frequency means the model has a more accurate sense of where each word is in a long passage.
Right.
That seems like it would be crucial for understanding the relationships between those words and the overall meaning.
Exactly. And it's interesting that Llama 3, which is the foundation for ChatQA2, was trained from the start with a much higher ROPE base frequency than Llama 2.
Oh, wow.
So they were really emphasizing those long context abilities right from the beginning.
It seems like Llama 3 was built to handle those large chunks of text from the get-go.
Yeah, it was.
And then when they extended that context window to 128,000 tokens for ChatQA2, they had to adjust the ROPE-based frequency to make sure that the model could keep up.
It's like upgrading the navigation system to handle a much larger map.
Yeah, that's a great analogy.
You need more precision to navigate effectively.
It's not just about making the context window bigger.
Right.
It's about ensuring that the underlying mechanisms can support it.
Yeah.
That ROPE-based frequency is a key part of that.
It is.
It's about making sure the model can accurately understand those connections between words in a long context.
This deeper understanding of how these models work internally is crucial for developing even more powerful long context LLMs in the future.
We've covered a lot of ground in this deep dive. We've seen the model's performance, we've explored RAG versus long context, and we even delved into the technical details like that ROPE-based frequency. But before we wrap up, there's one more thing that I want to touch on. The paper mentions how ChatQA2 uses special characters to separate documents in the text. Why is that significant?
It might seem like a minor detail, but it actually had a big impact on the model's performance.
Really?
Yeah. Typically, LLMs use special tokens, things like BOS and EOS to mark the beginning and end of sentences or documents.
Right.
But for ChatQA2, using these tokens made it harder for the model to adapt to longer contexts.
So they went with something simpler.
Yeah, they started using simple characters like S to separate the documents. And that change led to better performance. It seems like those standard tokens might have been signaling to the model to just ignore earlier parts of the text, which is not helpful with those long contexts.
It's amazing how something as small as that can have such a big impact on how the model performs.
It reinforces that we need to pay attention to all those details when we build these models.
It's a reminder that we're still learning how these models learn and how they process information.
Yeah.
And sometimes those unexpected discoveries lead to big improvements.
Exactly.
This deep dive into ChatQA2 has been really eye-opening. We've uncovered some fascinating insights.
We have.
From the model's performance to the interplay of RAG and long context, to those subtle details like those document separators, we've got a much clearer picture of where these long context LLMs are right now and the potential they hold.
Absolutely.
Now, in the final part of our conversation, we're going to explore one last detail. Table 5 from the research paper. It looks deeper into the comparison of RAG and long context models when faced with those super long documents. All right, let's dive into Table 5. It takes a closer look at how RAG and long context models handle those super long documents, the ones over 100,000 tokens.
Right. Table 5 specifically looks at those NQA and NMC tasks from Infinite Bench.
Okay.
Those involve answering questions within documents that are over 100,000 tokens long.
Wow.
It's a lot of text. They tested both ChatQA2 and Qwen272b Instruct, another powerful long context model.
So for those really massive documents, did RAG still come out on top?
It did. For those ultra-long contexts, RAG consistently showed better accuracy
Interesting.
for both ChatQA2 and Qwen272b Instruct.
So it seems like even with a big context window, having that targeted retrieval through RAG really gives those models an edge,
It does.
especially when they're dealing with just mountains of text. Do you think that advantage would apply to other types of long documents as well?
That's a good question. This research focused on those specific benchmark tasks,
Right.
but it does point to the potential of RAG in other areas. Yeah.
Like analyzing really long legal documents or scientific papers,
Right.
being able to zero in on the most relevant information within those massive texts could be really valuable.
Yeah, it's like having a research assistant that can go through and highlight what really matters.
Exactly.
This research has been fascinating. It's really shown how these open source LLMs are advancing.
It has.
And ChatQA2 is a great example of how these models are catching up to those big names,
Yeah.
especially when it comes to handling these long contexts. It also highlights the importance of our RAG and how it can improve how we interact with information. Thank you so much for joining me on this deep dive.
It was my pleasure.